Welcome everybody to our final hackathon session. That's great to have you on board. You all spent lots of time, or most of you spent many nights. So thank you for that. And I think we should go on with Jan Wiemer. Congratulations, Jan. You have the second prize. And yeah, I would say, let's start.
Yeah, hello everybody. So the background for my project. So in real life, I develop software to steer big automated warehouses. And in this logistic area, well, the business logic tends to be very algorithmic. So we have usually a heavier load of incoming events coming from hardware devices that we have to handle. And well, the algorithms that we have to implement are usually not. It is usually not possible to do it. Do them with queries. So usually, performance is a dominating requirement in this area. So this leads us to operate on transient data. So keep the data we need for the algorithms in memory, and of course, the events that are incoming have to modify some of these transient data, and this leads to the need of transactions. We have to modify this this data transactional, and this leads me to the idea to well, invent a little store similar to a map, where you can modify this transient data in a transactional manner. I call this a JACIS store, well, the acronym for atomicity, consistency, isolation. Durability I left out, so that it's only initially thought for transient data. We do not want to store them to the database or to the storage. We only want to manipulate the transient data in transactions. So the basic principles when developing this store, where I want to keep it simple, want only to add features that are straightforward to implement and stick to the standards, have no dependency, no magic, and will only focus on the really important use cases. So when I learned about MicroStream, this sounds like a very natural extension of this concept, because this was a straightforward way we can well, extend this store to be very durable, to provide the durability feature as well. And well, with this combination of the JACIS store and the MicroStream, we really have something like a little simple database for Java objects, without the requirements to have JPA annotations or think about mapping something like this. And we have great performance, which is absolutely important, and to provide the durability. Well, we really have introducing MicroStream to store objects in the store. The greatest challenge was to do this really in a performant way, because usually we have these stores are getting quite big. We have several thousand objects in the store, and a single modification should not become more expensive if more objects are in the store. So we have something like a sublinear time for inserting, updating, and deleting objects. And for this purpose, I have to do some experiments with different data structures to well, get it really in linear time, or in sublinear time, nearly constant time. Well, if you're exactly, it's logarithmic time because of the maps, but at least not linear time. Okay, and since this is a little bit theoretical, I also added a little demo project based on Helidon, well, where I can show how the store is working. And well, I share my screen now, I would suggest. So now I guess you can see my Eclipse environment. And well, one thing I really like in Helidon is that you can simply. Yeah?
Now I see it. I didn't see your screen. Now I see it. It's okay.
Okay, fine. One thing I really like in Helidon is that you can start a main class simply. And well, we are talking about transactions here, and what demo application should I use? Of course, I use a bank application, a simple bank application, and I start the Helidon environment with this application. Now Eclipse needs a second, but basically Helidon is starting really fast. And you can see in the logging that it creates the JACIS store. And well, here is the URL I can use to access the store. This little example store is really kept very simple. You see the browser now. I'll put the URL here. You see a little bank application with some accounts and account owners, a limit and a balance, and you can rebook some money.
Only my screen is frozen, or yes, now it came.
It's frozen or it's working?
No, it's just I see there's a big delay. Maybe it's my problem.
No,
maybe
it's on my side. The connections was a big latency.
But now we can see the browser. Now it's okay.
I can create an account here, and so I can rebook some money from this new account, and oh well, it's the amount. So now we have a little different picture here, and now I can stop the application to really see that MicroStream is working in background. And if I refresh it here, it should be gone. Yeah, it's gone. And I can restart it. So it should be running again. When I refresh now, then we have the same data here as before. So it was stored in a file using MicroStream persistence. The project is on GitHub. I added a lot of documentation for the project. You can browse it in the wiki. You see a complete manual here. And okay, any questions?
Yes, just from my understanding. So what you actually created is unit of work, right? So what you did is that every transaction gets an own copy of the data, and at the end of the transaction, you can merge back with the actual persistence. This is the goal, right?
Yes, exactly. So you can see it a little bit visualized in these figures. If a transaction accesses an object, it gets its own clone of the object, and we maintain, or I maintain, a version counter for the object. So so we use optimistic locking to detect concurrent modifications of the object, basically. Mm-hmm. This is the basic concept of the store, and yeah.
Mm-hmm. Yeah. So almost like Hibernate, right? So something like what Hibernate does behind the scenes, I would say, almost.
Yes, exactly. I'm coming from a company where we use Hibernate, and I was inspired, of course, by the optimistic locking concept of Hibernate. And well, when I evaluated the internet, there are some stores that or some concepts that use similar concepts. And I thought this is a simple concept where we can can solve the problem without too much complexity in the code. So you can still understand the code. I hope a little introduction.
What's this MVCC? Oh,
Pardon?
you implemented it, or what's the difference to the MVCC paradigm for the concurrency modification?
The multi-version, it is basically an implementation of this concept. You can put it this way. Yeah. So with a goal to keep it really very simple, the code very simple there.
Yeah, well, it's a valid way to deal with it. So you actually put transactional behavior on top of MicroStream.
Yes, and therefore I thought this is really a perfect fit, and I was well, maybe very happy to see MicroStream, and I thought this well, it's a great addition to the store there. Yeah.
So the main thing is I have a talk about MicroStream, and I always ask the community, if someone is here to implement MVCC on top of MicroStream, let me know. Now I have the solution, at least one. Perfect.
Very good. Any further questions?
Not from my side.
I have a question. How many nights you spent with
I wait for this question. Well, it's hard to say, but at least 10 nights, I would say.
Yeah.
It's interesting to see that everybody says nights. Nobody seems to work with MicroStream during the day.
Oh, well,
this is the question that Adam asks.
No,
he asks in nights.
Yeah, because nights is the fun, you know. A day you will do whatever. You have to do Scala, and nights you can have fun, right?
This is what I called real life in my introduction.
So only the real heroes worked at night, so that's why.
Yeah, thank you, Jon. Also, great presentation.
Real life in my introduction, yeah. Thank you.
This is, it looks, you know, if you read it, I thought you implemented something else, but it's really useful. So I'm glad that you presented that, because I suspected you did something else, but this is really useful.
Thank you for joining, everybody. Watch the videos, and also thank you very much for our judges. Bye-bye.